Hey guys, how's it going? My name is Briano Bruno. I am a software engineer that's particularly specializes in building Java-based applications. Most of my career has been spent building those Java-based applications. And today I'm going to be talking about generics, what they are, how they're used in Java, specifically where you've used them before. Because honestly, if you've coded in Java up until this point, and you got anywhere past the Hello World program, you've probably used a generic one way or another. So I'll give you the first example of what a generic is, and that would be used in an array list. So anytime you use really anything in the collections framework, whether it's an array list, linked list, hash map, when you're instantiating it, right, you may say like array list, and then you'll give these brackets, because if not, the compiler is going to yell at you. And you have to say what the array list is. Let's say it's an array list of integers. This is kind of what you would see, right? And when you're using an array list. So you're saying that the array list is of type integers. And what is that really doing? You're telling the compiler basically, hey, this array list can take anything of integers. So anywhere here in an array list where you're seeing E, you're able to replace that E with integer, basically in your head, right? And what that stops us from doing, right, is basically, let's say we can go to integer and we can add an integer, let's say 50, right? And that works fine. And similarly, we can go and have some integer equals integer dot get 0. So we're able to do that fine. But what can't we do? So we can't say integers that add 50 dot 0, right? We can't add a double to it. And we can't add maybe a string to it, right? Because here your array list is specifically made for integers, right? But what we can do is we can obviously change this to string, etc. And every time we're not making a new array list class, we're just using what the generics in array list. So let's go through, let's start making a print util, right? So let's go ahead and let's make a integer print util. So let's say you're taking in some private integer, right? And you'll have some constructor. And then maybe you have a method which is public void print, and then we'll print that integer that we just took in, right? Okay, cool. Now, we can go ahead here and we can say, okay, where's my integer? Let's say integer print util, right? Declare that. And declare value of 50, right? And then we can just call integer print util.print. Now, this all makes sense. Great. You have your print util. It prints 50. But unlike the array list where we were able to just kind of go into the brackets and change it to, let's say, a double, if we wanted this integer print util to now print out doubles, what would we have to do? Well, we'd have to copy this whole class. We'd have to rename it to double print util. And then we'd have to basically refactor everything to be a double, right? So anything that said integer, we want that to be, let's say, double val, right? And then this needs to be a double instead, blah, blah. Okay. So, and now, all right, now we have this double print util. And then we can go here and we could do double print util equals new double print util. And then we could do 30, right? That's 0. Let's say. And that's all fine and dandy, but think of it if you're maintaining this code base. And obviously this isn't a very basic requirement here, right? We're just printing out, and there's easier ways to do this. We didn't even need to make the util. Generics may not even be necessarily required in this use case. But take it as an example, right? Every time you have a new print util that's needed, every time a new requirement may come up, you're going and you're recreating this class. It's not simply like an array list, right? Where we can go and say, okay, now I'm using it for doubles. And this is the beauty of generics. This is what generics can be used for. So let's go ahead and let's think of how we would refactor this if we were to use generics. So first of all, I'll copy this so we have a nice building block, and we'll just call it print util, because now it's not specific to integers, it's not specific to doubles, it could be anything. Just as you see here in array list, it takes some kind of E. E is an interesting one. Most of the time you'll see it really as anything. It could be T, it could be K, it could be anything. Normally in hash maps you'll see like KV, and there's multiple. You can have as many different types in here as you'd like, but normally it would go with T. Great. So let's see what we can do here. We have our print util and we're giving it a T. So how can we refactor this? First of all, instead of taking integer, we'll take T and we'll kind of change this to be value, right? So T stands for type. We're taking in a type. That type can be anything. So the same thing here. In our print util, when we're constructing it, we'll take in a type of value, right? And then we'll just set this dot value equals value. And we'll do a print ln of the value. So now, unlike what we were having to do over here, we can go ahead and we can say, right? We can say, okay, I want to instantiate a print util. And just like in our array list, I want our print util to print integers. And we'll call this integer print util again. And then we'll call new print util and then give it the value of 50. So these two are effectively equivalent, but now you're getting rid of the extra classes. So now I can call my integer print util dot print, and this will go forward without any issues, right? So they're 50. Perfect. Now this is a very basic example, but let's dive in a little bit deeper. One of the cool things about generic, so a good example of that is making use of extends. So we can say T extends, and then in this case, maybe we could do number. And that gives us some extra functionalities here. So first of all, now we know that whatever T is in there is something that extends number, obviously. But it gives us some more functionality. So where previously we might, let's say, we might have not known, right, if what was coming in could be turned into an int. But now that we know that it extends number, we can do something like return int value of this, right? And then we could do value dot int value. And we'll call this print int value. And because that's extending number, and we've made sure that that requirement is there, we have access to those methods. So now if we go ahead to our integer print util, and we could say integer print util dot, sorry, that was private, okay, dot print int value. And we're printing the int value. And as you can see, it's 50. But again, if we made it maybe, if we made this into a double, which also extends number, right? And made this into 50.0, we would still be able to use the same print int value, and it will cast it to an int, or convert it into an int, basically dropping the decimal places. So the next thing we'll be talking about is wildcards. So let's bring up our example of our integer print our print util that takes an integer. Okay, and give it a 50. And wonderful, and let's say print util dot print, right? And this is the same scenario that we've had before. Our print util will go ahead and print out 50. Now let's say we wanted to extract this into a method. So we'll go refactor this and extract method. And instead of doing this, right, we'll go ahead and say print util equals new print util. And we want to pass print util into the method. And we'll have print util integer print util here. And okay, perfect. So now we have a method that takes our print util and prints it. But there's an issue here, right? So let's say I want to change this to a double print util. Everything's going to start breaking, right? So let's say 50.0. This is failing. And why is it failing? It's failing because it's requiring a print util of integer and it's provided a print util of double. So let's think about it. Can we put maybe object here? As you can see, we still have the same issue. We're requiring object, but we're provided double. So this is where Java provides us what's called the wildcard. The wildcard allows us to say, I don't know what is the type parameter of a print util, but I can take in any print util into this method, and I'm able to go through and execute my code. So your example here is we're still able to call the print util.print on this print util. If I go ahead and run this, you'll see that the 50.0 still comes up, and it'll be okay for anything. I could pass an integer here, I could pass a double, I could pass object. Anything will work because this wildcard is saying I can take anything in here. We don't care what it is. Alright guys, so with that being said, I want to thank you guys for watching my video. Again, my name is Bruno. If you guys enjoyed this quick video on generics and wildcards in Java, then please go ahead and like the video so other people can see it and subscribe for more Java content as well as just software engineering content in general. And be sure to check out the other videos on my channel because there might be something that you'll like. Have a great day guys. I'll catch you in the next one. Bye.